been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for Geometry 8.4. We're going to look at properties of rhombuses, rectangles, and squares. So the first is just the definition of the polygon. So a rhombus is a parallelogram with four congruent sides. So that means that this is congruent to that, which is congruent to that and that. And of course, if it's a parallelogram, everything true about a parallelogram also holds true for a rhombus. A rectangle is a parallelogram with four right angles. So a rectangle is a parallelogram. So again, everything that's true for a parallelogram is true for a rectangle, but it's special in that all the angles are right angles. A square is a parallelogram with four congruent sides and four right angles. So a square is a parallelogram. It's also a rhombus. Why? Because a rhombus is a parallelogram with four congruent sides, which this has. But a square is also a rectangle because it's a parallelogram with four right angles. So a square is both a rhombus and a rectangle. The rhombus corollary says that a quadrilateral is a rhombus if and only if it has four congruent sides. Remember that the if and only if means that it works both P then Q and Q then P. So a quadrilateral is a rhombus if and only if it has four congruent sides, which means if a quadrilateral has four congruent sides, then it is a rhombus. And if it is a rhombus, then it has four congruent sides. So it works both ways. The rectangle corollary says that a quadrilateral is a rectangle if and only if it has four right angles. And the square corollary says that a quadrilateral is a square if and only if it is a rhombus and a rectangle. So these corollaries are used, you may want to add this to your notes. The corollaries are used to prove that a quadrilateral is either a rhombus, a rectangle, or a square without having to say that it's a parallelogram. So you can sort of skip over that step when we look at these corollaries. All right, this theorem says that a parallelogram is a rhombus if and only if its diagonals are perpendicular. So in a rhombus means that all four sides are congruent. It's a parallelogram. The diagonals are perpendicular. So that means that that diagonal and that diagonal intersect to form a right angle. That is true if it is a rhombus. A rhombus also is a figure where each diagonal bisects a pair of opposite angles. So what this means is that this diagonal bisects this angle, which makes that congruent to that, and this congruent to that. And then also, when you draw this diagonal, it bisects this angle, which makes those congruent and these congruent. Now, remember, in a parallelogram, this angle, the opposite angles are congruent. So if I bisect two angles that are both congruent, then when I bisect them, they're also congruent to each other. All right, a parallelogram is a rectangle if and only if its diagonals are congruent. So this is a property of rectangles, that the diagonals are congruent, which means if I draw my diagonals, let's go back to a parallelogram. In a parallelogram, this is congruent to that, and also the other diagonal is also broken into two congruent parts. But because the diagonals are congruent, so let me put it this way, BD is congruent to AC. Those are the diagonals. And because that's true, if I call this point F, then now AF is not only congruent to FC, but it's also congruent to DF, which is also congruent to BF. Okay, so all four of those segments will be congruent in a rectangle. So the hard part about this is that you first have to start with, is it a quadrilateral? If yes, then you ask, is it a parallelogram? If yes, then you have to understand that everything about a parallelogram would be true for that. But beyond being a parallelogram, it may be something more specific, like a rhombus, a square, or a rectangle. And we'll look in class more about how to know the difference and apply these properties.
I've been waiting way too long.